Hello, everyone. Welcome to the Data Science Mentor Program. My name is Pablo. I am founder, host, and coordinator of the Data Science Mentor Program. The Data Science Mentor Program is an accelerated learning cohort. We use examples and mentorship to help folks learn data science from scratch. And in today's session, we are going to be starting out with introduction to machine learning. Now, today's session is interesting because we're not going to write code. We're just going to we're going to interact and talk about what machine learning is. As always, the technical side to learning data science is not as important as the intuition behind it. Now, the intuitions are super important. Why are you doing what you're doing? What's the reason for it? What are you looking to solve? And I think that's what we're going to talk about today. So, as usual, I'm going to use a lot of documentations with the Markdown. Then we'll talk about we'll talk about it from scratch. We're going to have a very simple definition, and then we'll look at an intuitive explanation, and then we'll go on to talk about a real life example of what it is to talk about ML, machine learning. Right, I think this is really important for anybody getting started to have like some fundamental knowledge or some intuitive knowledge of what machine learning is before jumping in on it. I think a lot of learners have skipped the introduction to Python stage, which is basically a tool to help us build our competitive edge with data. They skipped the introduction to numerical computing, which is a critical aspect of machine learning. We're going to, as we unravel machine learning as simple as we can, you see that using numerical computing is such an integral part to it. So we're going to be looking at data and tables as matrix, as samples of the matrix, and these matrices are what we have dealt with in introduction to NumPy for data analysis, right? And then, of course, we're also going to visualize. We're going to visualize data, and we're going to pick up data and then visualize data. So that's why it was important for us to get through the sessions for introduction to pandas for data analysis. And then, of course, visualizations are important. That's why we had introduction to visualization sessions before now. So if this is your first time checking this out, there's a lot you need to check up on just to learn, right? But again, feel free to jump in on this and then pick a few things. Now, if you are watching this as a live stream, feel free to drop a message or a comment in the comment section. If you're here live, feel free to use the in-call message session, to share anything you have. Okay, that's all right. If you're having if your network is not so good, that's fair. You would receive the recorded session of this, so that's fine. Right, apologies for that. And so if you're going to be watching the recorded session and you have questions, please drop the questions in the Telegram channel. So the first thing we're going to do is we are going to define machine learning, right? So we will define machine learning. I'll try as much as I can to use a lot of the markdowns. So let me make this bigger. So here we're going to define machine learning. I'll call it ML for short. So this is what we have here. Now, it's certain you must have seen shout out whoever provided or created this first machine learning definition, because it's pretty simple, right? And I think it has helped a history of folks who are joining into the data science domain, right? So machine learning Machine learning is a way to teach computers to learn from data and make decisions or predictions without being explicitly programmed. Again, I'm going to put that. That's what I'm going to write. It's not my definition. It's a definition that's out there. So, what ML is. So it's a way to teach computers to learn from data, right? And then make decisions or predictions. Without being explicitly programmed. Right, so this is it. Without being explicitly programmed. Let me make it a little large so we can see this. Right, so without being explicitly programmed. Now, it's really important at this point to talk about this concept. The competitive edge in business or problem solving, and the equation of problem solving is decision making while learning on the data. And for the longest time, we do a lot of data analysis, answer questions, look at leading indicators and answer questions, or look at lagging indicators. Lagging indicators are information we've collected, and then we can make decisions. But when we're trying to make decisions using leading indicators, which are maybe indicators yet to arrive, or indicators coming real time, or information coming real time. How do we work with that? Because at this point, we can't start programming all this into perspective. So that's why machine learning is such an important. So it's so important, right? So again, I'd like to. The next part is to have an intuitive explanation. Let's have an intuitive explanation of what this is about. Now, with an intuitive explanation, we're going to look at what traditional programming is about. So here, traditional programming. With traditional programming, we write rules and then the computer follows them. So just like we're trying to analyze data, we write certain rules and the computer follows. You see that the IDE is there with the Python in the back end, the Python engine in the back end, assessing all the rules we're making, ensuring we're following, we're following all these rules, following the heuristics, and following the documented rules for writing programming and the intuition behind them and the logic. Now, if you write that correctly, the computer follows them. So that's the first one, right? Now, in comes machine learning. With machine learning, you give the computer examples, right? And then the computer figures out the rules. So here you give computer examples. Now these examples simply data. Now with this example, the computer figures out the rules. I mean, it's such a fascinating way to look at it, right? So all the computer has to do is for you to feed the computer with data, and it starts to figure out a pattern. And once it figures out a pattern, it gets to understand that it's basically thinking, well, there are rules to this. And I might as well follow this rule. And by following that rule, if you give it new data, it's going to say, oh, this is what I think is going to happen. With this data, this is what is important. Right? So that's what machine learning is. Very light on it, right? Now, what we are to a lot of ends, right? Machine learning is competitive edge. Like, think about the financial sector. Think about what happens in the financial sector. Think about the products offerings in the financial sector. You have banks offering services for folks to save their money, for folks to keep their money safely. And to that end, banks create new products like insurance, products like loan facilities, products like overdrafts. And you think of a situation where a bank has to be sure you would not, or a customer will not default on a loan. How do they figure that out? They need some examples. They need past data to see if they feed it to the computer, and the computer starts to figure out, well, if I look at a row of data and I look at certain features in this row of data, just one row, is it possible to figure out if the individual with these features will default on a loan? Now, with just one row of data, that's not possible, right? But when you start to introduce thousands to millions of rows, then then it starts to make some sense. And what that means is that with all this feature, there is a certain feature that is an indicator feature that says it's a label. It's given a name, a label that says, oh, with me, you can tell if someone will default. So it might be yes, or it might be no, or it might be not sure. Situations like that. So this is what it is. So now think about it. If you think about machine learning in your everyday life, you have kids. You say you take all the data that your kids and all the actions they've had, if it was possible, and then you store it in a computer, and then the computer can tell if your kid is going to do something. Imagine if you're able to, hack that sort of stuff. So this is just what it is, but think about it in terms of real life. Now, with real life, I'm going to now introduce real life examples, right? And I'll try as much as I can and to make this real life example really real life, right? So here I'm going to call this real life right? So we look at a real life example. Say you want to teach a computer to identify apples and bananas. Again, you would have seen a lot of these things. If you've watched YouTube videos, you'd have seen a lot of them. You want a computer to identify apples and bananas, right? So what do you do? So here, what name do I call it? So what you want it to do is you want it to identify apples and bananas. So this is what you want it to do. You want a computer to identify apples and bananas. Now, you don't basically tell the computer that apples and bananas, what the features of an apple or a banana, right? You don't tell the computer that the apple is round, You don't tell the computer that the banana is long or it's almost always like yellow, or you don't tell the apple that bananas are round and they have different colors. It could be green, it could be light green, it could be red or like red or whatever color that makes um, the apple. You don't tell it all that. So, again, you don't tell the computer what apples and bananas look like. You don't do that. Now, instead, what you're going to do is you're going to show lots of apples and bananas, and the computer is going to find out that there's a difference between these two features, right? So now what you do is you show the computer lots of apples and bananas. Now, what the computer does is that it finds patterns. So, finds pattern. Because sooner or later, the computer is going to be like, okay, I notice now that there's this stuff that is an apple, right? This stuff, and it doesn't know it's an apple, knows that it's round most of the time, and then this other stuff typically is long, and it's different. And then immediately it starts to create a rule, and it says, look, if there's this guy looking this way, and there's this guy looking this way. Now, what that means is if in future I just get to show it another some that comes through like an apple, it's going to say, oh, that stuff is similar to something I've seen before. And if it gives it a name, I say, oh, that stuff is number 1. That's number 1, and that's number 4, because it gives it. So because it looks like something I have seen before. So that's basically it, right? And of course, it's pretty simple in to this end, right? But what we have here is if we're using traditional programming, what we would have done is we would have an input, right? And we'll have an input where we'll create rules, and then there's definitely supposed to be an output. So that's what we'll create rules, right? So we'll have rules, and we'll say, look, we'll put in an input and say, look, there's a bunch of rules, and at the end of this stuff, we're going to what you will see if you see some certain rules that look red or green, look round, look this and that, we are supposed to have an apple. Now, if you follow this, so you probably tell with traditional programming, say, if there's something that looks like this, if it looks like this, if it looks like this, and its output is supposed to be something like this. However, when you introduce machine learning, what you're basically saying is we have an input, and I'm going to definitely share its outputs, because once it sees inputs and it sees outputs, then it's definitely going to think to itself and say, all right, then maybe I see something is happening here. And then I tell the computer to learn. Right? So you tell the computer to learn. Right? So now you just keep feeding a computer with images, right? You keep feeding a computer with images, and you keep feeding the computer with images, and then the computer starts to find out if something, if there's something that makes a lot of sense. right? So this is basically what we're going to do. Now, what makes this really interesting is it can be used in real life to solve problems, right? And that's what we are going to be doing in this session, of the machine learning session of what we have. We're going to solve problems. Now, what we're going to do is we're going to find examples as we proceed, and these examples are going to serve us as we proceed on the different ways to do it, and different ways to perform machine learning. Now, the next thing we want to do is we want to look at their categories of machine learning. And it's important that we share these categories. We have 3 categories, but we're just going to be looking at 2 categories, right? So, so here we're going to look at categories of ML. And the categories of ML, we have supervised machine learning. We have supervised ML. And 2, we have unsupervised ML. So these are the ones, right? Now we're going to look at these different ones, and for everything we look at, we would basically break them down in the examples in these areas that are very, very popular. Now, first, we are going to look at supervised ML. Now, with supervised ML, what you do is you give the computer labeled examples, right? Which is what we've mentioned here. So you give the computer labeled examples. And what the computer does is it learns to predict the label. It learns to predict the labels for new and unseen data, right? So it learns to predict the labels from new and or new/unseen data. So again, the Apple thing comes in with labels. You keep showing it labels, and when you throw in something new, maybe after showing it bananas and apple, then you bring in an orange, and it should be able to say no. Right now, a typical example, which is almost always been used, is your computer, is your email. In your email, you receive mails, right? Right. So very, very, I'll call this a popular example. Is the email spam detector. Now, at every time you check, anytime you check your email, there's always a situation where you find some emails have been classified as spam, right? Right. So the computer learns to classify the emails you receive as spam, right? So you receive an email. The computer figures out the spam and not spam. Right. So how does it do this? Now, this again, you would, again, like I mentioned, you would almost always see this as one of the popular examples, because it has been here for a bit, right? Right from Yahoo Mail, folks will look at their emails and you'll find out that some mails are spam. Why? Right? So the computer learns from past emails, it's been fed past emails. So what happens is, remember how we started out? We started out with input, and with that input, what you're giving is email data. It's been fed email data. Right? Now, when it's fed email data, it gets to understand by creating by creating a model, right? It gets to understand by creating a model that makes it understand a bunch of things. It gets to look at it. It's like it's not like it gets to understand. The first thing is we feed it data, then get to create a model. We get to show it a mod that look, by creating this data, we give it data, and we sort of curate what we've given it, right? And then at the end of giving it this data, because of course the curating part is you typically want to clean the data if the data is all over the place, right? But at the end of it, what we are looking for is an output, and part of the output, and it's going to have a label, right, that says, look, this data we've given you, some of it are spam, some are not spam, and it's going to figure that out, right? And it's by doing this, it has an input, just as we've shown, an input, and there's an output, but in between it's learning stuff. In between it's figuring out something, and eventually notices that we have there's an output. It's a spam or not spam, right? So this is what happens. Now, it's important to note that while we're looking at unsupervised machine learning, there are some examples of its application, right? One of the examples of the application of machine learning is called a classification task, right? So just like this guy over here, this is like a classification task because he has to classify spam or not spam. So it's important for us to think about this. So so this is example of example of a supervised machine, example of an example of an application here, example of an application, and this is where we say classification. We call this a classification task. I hope that really works. The example of an application is a classification task for supervised machine learning. Now, when we talk about a classification task, what are we looking at? So here, what we're looking at is we have labels, and with these labels, we get to classify our output. So we are here. What we're doing is we are classifying outputs, right? Because remember here, this is a perfect one here, right? This is a classification example because the output is spam or not spam. So the output could be yes or no, or the output could be true or false. The output could be white or black. So here, you're given a set of labeled points, and you now use it to classify unlabeled points, right? So here you have labeled points. Then you use it, to you use unlabeled points to classify unlabeled points, right? So here, the labeled points are the input data you see over here, right? Unlabeled points are going to be the unseen data, right, that we talked about. So it's have to look at unseen data, like, okay, what's this? Now, the data is almost always like is a two-dimensional, it's almost two-dimensional, right? And we would have one of two classes, right? Telling it one, there's a representation. Maybe it could be blue, it could be red, it could be white, it could be black, it could be female, it could be male, it could be default, it could be not default, right? So this is what it is. So it's a very good ways to look at it is predicting discrete predicting discrete labels. Did I promise that we're not going to write code? Yes, I promise we're not going to write code. But please just forgive me a bit. We'll write a very tiny code so that we can visualize some stuff. So before then, I just because I always forget it. I just looked at Stack Overflow, and you can see over Stack Overflow. I'm just going to copy this, right? So I'll paste this here. So here I'm going to import. I import image, but inside image there's something called IPython display, and I'm going to have a file name here. There's a file name. Let me see. It says classification. I want to show us stuff. So I run this, and so I want us to see this. Now, so you can think of this as what we have here as input data that they're discrete here. You have some discrete data here, and over at the other end, you can see that we have another discrete data over here. Now, what we are trying to do is, if we think about this data as this guy's being spam, maybe a spam is a mixture of spam and not spam, or is a mixture of blue and red features. And part of what we're doing, because they are features, is we're looking for a model that can simply classify this into two groups, right? It's to basically separate them. Now, if you can separate them by understanding their different features, right? But by understanding their different features, if it sees new features, then it gets to know, okay, this is what it is. So now it gets to classify them into two. So the whole stuff you see here is a data set, right? So that's basically what it is. Right now, with this data set, it has two features, so that's what it is. But think about in real sense, the data wouldn't have two features. It might have 10 features, independent features that makes you figure out a label. So this is one of it. This is like a classification situation. That's one. Now again, like I promised, I wasn't supposed to write code in any way. But the second example is in our first example. So in our first example, we looked at a classification task. Now, the next example is let me just copy this. The next example in the supervised machine learning application, the next example is called a regression task. Right, it's a regression task. Now, with regression tasks, it's different from the classification task. Here, what we're going to be doing with a regression task is we're going to be predicting continuous labels. We talked about predicting discrete labels. Here we'll be predicting continuous labels. Oh, is it called? Yeah, We predict continuous labels. Now, what is a situation for predicting continuous labels? So you can see right here, we have this is a classified like blue or red. But imagine a situation. So again, let me just take this guy here. Imagine a situation where we have this. Let me remove this. Where we have data that looks like this. Now, here now, the data is no longer classified. They're sort of continuous. So they are all in together, right? But here, the type of data we'll be using is we'll be predicting stuff, right, that is not classified but continuous, right? A very good example is, imagine predicting the price of a car, right? So think about it at this point, right? You have features, you have an input, which is the data. So here you can see that we have an input, which is the which is basically features of cars. So which is this? Then in between, right? We're looking to get out a model, right? And the model at this other end is we're going to have an output. And the output is supposed to be the price of cars. That's what we're trying to predict. So you can now see that this is not black or white, right? The prices of the cars are just going to be different. It could be, if I'm talking in Nigerian terms, it could be 5 million naira. I'm talking in, say, maybe dollar terms, we're talking maybe $5,000 or so. Cars, is a car worth $5,000. Maybe some other car is worth $4,925, or some car is worth 4.9 million naira. Some of that nature, right? And so it's different. So now it's no longer discrete in a sense, right? Their numbers of the way it works is, you know, we cannot fit this like this guy would have been able to, you know, fit things like this and just create planes. And as we fit these planes, we're going to say, okay, with these different planes, they're going to be different classes, right? But with this, we cannot fit planes, right? What we want to do is we want to create a system where it's sort of like going to exclude, is going to, you know, predict it continuously. It's going to look at data and say, oh, look, maybe around this data, there's something different here, right? Maybe we have something different here, right? And maybe here we have something different around here, right? Because it's continuous. So the model here is going to be different, right? So that's how we'll typically want to make predictions, right? And when we're done by creating this model, we would now take, we know we have known data, and we'll now introduce unknown data. And we're going to now look at the predicted model, the predicted data, and then look at unknown data and see if we can find something, you know, pretty similar, right? And let's say, looking at the ones we have predicted, we look at unknown data and see, is there a way we can, you know, make sense of new data with this, right? So now, by the time we're done with the data we have, we now find out with the predictions we have done from our car features with our car prices. Now, can we look at unseen data and also a new car is rolled in and say, with this new car, can we predict stuff based on the features that we've seen here? Can we make some price predictions on these cars? It's like that. It's there. Another way is like maybe predicting the distance of a trip, or predicting how much you pay for maybe Uber or like Bolt or a boat trip. So this is what this is, right? Another we remember that we mentioned we've talked about supervised machine learning. We're now going to talk about unsupervised machine learning, right? We're going to talk about unsupervised machine learning. Now, let me see this. Let me put this here. Now, we don't supervise machine learning. Something is really interesting, right? We are with supervised machine learning. We're trying to build a model that will predict labels for new data. Well, unsupervised machine learning involves models that describe data without referring to their labels. So here, we want to describe data without referencing labels. Without reference to labels. So you see that? So now we have an input, right? It's data, but the output is not definitely looking at labels, right? What we're trying to do is at this point we're trying to, it feels like this is typically what we have. We have input, right? So maybe we have input, and really interesting stuff. We have input and we have like email data. And in between, right, we have is a model. But what this model is looking to do is that its outputs are going to be possible groups. So the output is not going to be a discrete label or a continuous label. We're going to be looking at groups, or we're going to be looking at clusters. We're trying to understand the data by understanding it, by figuring out if they have like clusters with them, right? So it's a very, think about a possible example is if we have bank accounts. Look at that, bank accounts. Now with bank accounts, we will have several cluster bank accounts. The model, so there's a question, right? The question is, what is a model? Now, the model is the understanding, is what the computer learns, right? Is what the computer learns in order to figure out this output. So what is that? It's the figuring of that out, is figuring that output, right? Is the computer learns stuff, and that model is basically saying, following a certain pattern, I can understand what I haven't seen before. It's typical of what human beings do. We make friends, right? And to that end, we sort of capture cues. We sort of capture social cues about certain people, and these social cues make it easy for us to point out folks who are our friends, or folks who we assume are not our friends. Now, in the friend-making experience, we build a model of the people we predict to be our friends. And so that's why when you see somebody for the first time, it's sort of like an awkward moment, right? Then over a period, with patterns, with relationships, with encounters and all, next time we see someone, we're going to be like, hey, Grace, what's up now? How you doing? And we've built that, right? Now, at any point, because you consistently have this friend, at any point, you've built a lot of, features about the person. This person is this. You accept some of them you don't accept, some of them you compromise, right? And so that model is now in your head. So every time you see your friend, you guys either have a handshake, and all. Over time, you're going to have friends. Sooner or later, you're going to start realizing that there are some people that act just like Grace. And you sort of like start, once you see something similar to what Grace has, you start to say, well, this person can be my friend. And somehow it turns out to be that this person can be your friend. And boom. You know, sometimes you try it, but sometimes it turns out not to be and becomes an awkward moment. You know, you have a situation where you assume somebody is a friend, and then you guys you reach out and say, oh, but it turns out that the person says, oh, no. Or you guys just meet, and because the person has similarities and that other person has some similarities that they built over time about their friendship model, or they can say, oh, we can be friends. So it's just basically that. It's also similar to what we do as individuals, as human beings, when we figure out dangerous situations. We are versed to dangerous situations. A lot of human beings are. And so most times our brains start to click and tell us, oh, this looks like an enjoyable situation. And the body just starts to open up. It's receptive to it. If it thinks it's dangerous, the body starts to close up. So that's basically what that model is. It's basically, eventually finding out the way we make that decision that puts this in groups. Same thing is when we come over here. You get me inputs, we understand this model, and we can now understand the prices, right? So features creates a model, we can now predict the prices of the cars. But with this input, this is example data, right? And these features would almost always have everything we're looking for, and we'll find a pattern to get into that output or the labels. And with that, we now find a way to predict the prices of the car. And remember, for every we have machine learning problems exist. Machine learning problems are saying, can you predict this? Can you predict that? Right? So it's ideal to also talk about, your question is really great, machine learning problems. So these are basically the problems, these are basically the problems machine learning can solve, right? So you can see that, these are the different ways we can now start to think about, what are we trying to solve for? We're trying to predict prices. We're trying to predict prices. We're trying to predict classes. We're trying to figure out groups. Trying to figure out groups, right? So, or clusters. And if something is good enough to be a machine learning problem, then it's good enough to, figure out which model can make it easy to get to achieve some of these things. So whenever we get the data, we need to model our data so we'll be able to make very good predictions. So that's basically what that is. Right. So final part of it is we're here now looking at clusters. Right. So here I'm going to have image. And with image here, let's see. It's image here, just a second. So, okay. So now you can see, now some data will have clusters. They would come in clusters, and if they are in clusters, you probably also want to break these clusters apart, right? You probably want to break these clusters apart, and when you break these clusters apart, they start to make sense. So you can see this. Now, if you now have an image here, and we have like say this. So now you see that when you put them in, this at first didn't have to just input data, and all of a sudden they now have clusters, and maybe different clusters, right? You have this cluster here. If you're thinking of them as bank accounts, right? This is not a cluster of maybe people who have like $100,000 in their account, or $5,000 or $200, and there can also be this group, you know, with different groups. Right, there's also another group over here. So breaking things into clusters now make for problem-solving situations, right? With problem-solving situations like this, when we find a cluster, maybe a cluster of folks who can buy cars, a cluster of folks who can buy houses, a cluster of folks who can default in their, who we think might default in their loans, right? You can put them in clusters, right? And with you know, what clustering does is typically some of the way cluster works is that an unsupervised machine learning model will find a way, you know, to automatically put this data into, you know, clusters and give them labels. They're like cluster groups, right? So this is basically what this is, right? And there are different, there are many ways. There could also be, there's another unsupervised machine learning technique where this algorithm sort of like scales down data, right, to find the essence of the data. So there are different ways, and we're going to look at it, right? So with this, we've seen unsupervised machine learning where you look at creating clusters, right? There's also an unsupervised machine learning technique that is also called dimensionality reduction, right? So here is you basically look at your data, right, and then try to pull out a low-level representation of the data. So these are things we're going to look at in this session. But again, I want us to look at these things and make sense of what we're going to be looking at. It's really interesting how this is, right? So in summary, what we've looked at is that basic types of machine learning approaches, right? They're really important in solving real-world problems, from finance to health, to sales, and all. And basically, with supervised machine learning, what you have are models that can predict by looking at examples. And with these examples, they have labels, and they break them down into 2 or more categories and say, okay, it's either white, black, right? There are models which are regression models that predict continuous labels like pricing. In unsupervised machine learning models, they are typically not focused on labels. What they do is to either cluster or to either scale down the data to see if there are different essence in the data. So that's what's called dimensionality reduction. So that's basically that. I told you guys we would not be writing much of the code, though I had to write a little bit of code for us to visualize stuff, right? So, but basically, this is what it is to look at machine learning before we go into what machine learning in itself is, right? So this is the part where in the next part of what we'll be doing. In our second part, we're going to now look at the tools or the algorithm or the APIs that we're going to be using for machine learning in this course in understanding it. We're going to now look at the API that makes it easy for us to, you know, take an algorithm, and this algorithm can do certain things, right? And so, yeah, so that's what we're going to be doing in our next session. My hope is that this session was for you to take your time and watch this video and just see this intuition. This intuition is really, really important, right? We have questions. Now, if you're watching the live stream, please feel free to drop a question in the comment section. If you're live with us, you can also drop a question, or you can ask a question. If you're watching a recorded session, please feel free to drop a question in the Telegram channel. We're ready to answer those questions for you. Yep.